Good.
Doubling up. Roger, roll with Planet.
Water towers can fly! Yes!
Tango Delta nominal.
Flight outside SCE off. Say again, SCE off.
Yikes. You bet. Concur. We don't need any more of these.
Okay, y'all, you know the drill. We know the drill, trying to get things working here today. John Galloway for NASASpaceflight. Let me know if you can hear me, and let me know if you can see a little bit of a hazy view of a Falcon 9 that 5 minutes ago completed its T-minus 20-minute vent, but just let us know that things are at least working a little bit and there's no fog. That's right, that doesn't look like fog today. It is time for a launch from Slick 4E out at Vandenberg. SpaceX launching some internet satellites on the Falcon 9. Jack has rolled out, but he's rolling solo today, trying to set up a lot of equipment for us and not a lot of time to get it done, especially when the gremlins bite. But we are here to do the thing now that we've got it working. I've got some friends with me. Wouldn't do it solo. But please welcome to the stream, Mr. Chris Gebhardt, Associate Assistant Managing Editor for NASASpaceflight.
I like that, the Associate Assistant. I like that, yes.
I think I said it wrong at first, and then I corrected myself, but we'll just go with it.
But it's kind of like, assistant to the regional manager, right?
There
I kind of like that. But hello, Dus. I'm doing good. How about yourself?
I am hanging out. That's the plan for today. Also with us in the channel here, we should have Mr. Thomas Berghardt, News Director for us.
Thank you, Daz. It's good to be on another Starlink launch, this one from Vandenberg, California.
All right, Thomas, thank you so much for joining us. You have 14 minutes and 24 seconds to answer questions. Go.
All right. Thank you everyone for tuning in. Let's give the overview of today's flight. In fact, Chris, do you want to give us the rundown while I pull in some questions from chat? Because again, tag us at NASASpaceflight. We'll bring some questions in.
Of course. So welcome to a Starlink launch. I know, right? It's been a while and I was getting nervous myself. But another batch of Starlink satellites to help populate SpaceX's space-based internet constellation are getting ready to launch. This specifically is the Starlink 3-3 mission. The first 3 indicating that it's going to the third orbital shell, which has an orbital inclination of 97.6 degrees. And then the second 3 means it is the third in the sequence of those that have planned to launch, with 3-1 and 3-2 launching earlier this year, also from Vandenberg. So today, the Falcon 9 is going to be bringing 46 new Starlink satellites into that third orbital shell. It will deliver them into an initial orbit of 308 by 321 kilometers, inclined 97.6 degrees to the equator. And then after their deployment, the satellites will perform a series of orbit raising maneuvers to get them into their correct plane and into their correct orbital altitude. And eventually this shell is envisioned to operate at the roughly 560 kilometer altitude range. Right now, not counting this particular mission that is launching today, 92 of the 348 Starlink satellites destined for Shell 3 have been launched, with another 46 scheduled to go up today. So making quick work of filling Shell 3, which is not the biggest shell of the constellation. During the launch, though, we will get a recovery of the booster, just as we have come to expect. The booster on this particular flight is 1060-10, so making its 10th flight today, and it will aim to land on Of Course I Still Love You, which is located about 636 kilometers downrange. And then GoQuest will be the one that will fish the payload fairings out of the water for their recovery. And in case you are wondering, Booster 1060-10 flew the Crew 1 and Crew 2 missions for NASA. It launched the Sirius XM-8 satellite, the CRS-23 Cargo Dragon to the International Space Station, the IXP X-ray Polarimetry Explorer telescope back in December of last year, 2 transporter missions, numbers 4 and 5, Globalstar FM-15, and 1 previous Starlink mission, 4-7 from the Cape. So that's an overview of our flight today, and a little history on our booster as well.
Yeah, this is the first flight from the West Coast on this booster. Oh, hey, Jack, from the field.
Jack,
how's it
just
going?
jump in.
Yeah, I can jump in, right? Is that allowed?
You
I was just
certainly
going to say, I like how Starlink is like where all these boosters go to retire now. It's like, I'm going to launch some crew and I'm going to launch some communication satellites and I'm going to retire on some Starlink.
Exactly. Yeah, this is actually the first mission for this booster from Vandenberg. It lived all of its
Yeah.
previous 9 flights were from Florida, and then SpaceX shipped it over to aid with the West Coast cadence, actually starting to ramp up that third shell, like Chris said. So Booster 1061 making its way to the West Coast and getting treated to a fogless first launch. I think Vandenberg's going to put on quite the impression for this booster.
We get spoiled.
Yeah, really. I want to bring in some questions. Thank you for the overview there, Chris. We do have a question from Rich asking, is this launch going north or south? And this flight will be flying south towards that 97-degree inclination orbit, which is basically a polar orbit. All of the missions from Vandenberg fly some version of south or southeast or southwest, depending on what exact orbit they are going to. So southbound trajectory for today's flight. And another question this we can talk about for sure. Who is using Starlink satellites that go into a polar orbit, Chris?
Yeah. So the goal of the overall constellation is really to provide that complete global coverage, right? So there are two kind of ways to think about this. Some of the primary uses of those would be ground receiving stations in the Arctic and Antarctic regions, or the really, really high latitude areas like Alaska, northern portions of Canada, extreme northern portions of Scandinavia, Iceland, in the northern hemisphere. And then the land masses in the southern hemisphere aren't really don't extend it an equivalent distance down toward the South Pole. So you would really be talking about the research bases in Antarctica that would be using them. So those would be the primary users, because those would be the satellites that do come directly overhead. But honestly, any one of the ground stations anywhere on the planet could actually ping one of those polar satellites as it comes over some of the more equatorial regions in its orbit. So there you go.
Yep, there you go. Thank you, Chris. As more questions come in, I do have a couple of super chats and things I want to acknowledge as well. Want to thank everyone for their support for our streams. Really quick, Michael with the PadRat membership and Starship 24 with the Red Team membership, as well as a super chat. So thank you, Ship 24. Really quick, a very generous $100 super chat from Jerwa. That is super, super generous and goes above and beyond with the support. So Jerwa, thank you so much for that support. Says, thank you, Carson. I have no idea what that's in response to, but I appreciate the message there. We do appreciate the support as always. I'm going to bring in some more questions here. Mike Guru asks, is this a return to launch site or an RTLS mission? No, this would be a drone ship recovery, and that ties in with most of the Starlink missions where the drone ships are used because that maximizes the amount of satellites they can put on any particular mission. Basically, the number of Starlink satellites, which does vary from different Starlink missions, changes slightly because of what orbits they're going into, the altitudes and inclinations. But that number is basically determined by what's the maximum number of satellites we can deliver to this orbit while enabling a drone ship recovery. They don't want to go expendable because then they would lose all their boosters very quickly. For that high launch cadence, they would need reusability. But they also don't want to limit themselves to return to launch site missions. They can go with drone ship recoveries so they get the boosters back but are still maximizing the payload to orbit. And so that's where the number of satellites comes from. And today's mission is a drone ship recovery. Of course, I Still Love You is stationed downrange about 636 kilometers. Thank you, Chris. Downrange for the drone ship recovery. There's also a vessel Go Quest stationed downrange to enable fairing recovery for today's flight. So the full complement of recovery vessels out in force today. Some other questions that have come in here. Silas asks, I read in the article for today's launch that there has only been a single launch for Shell 2 so far. What's the reason for that, and when will we see more launches for Shell 2?
Yeah, so basically, SpaceX's overall strategy for building out this constellation is to first really build out the orbital shells that are going to cover the widest swaths of the population centers where they're trying to get this coverage, right? So like they want the lower part of Canada, North America, Europe, they really want like the large population centers covered. And that was primarily covered by Shell 1 and Shell 4, which launch into the 52, 53 degree or 55, 53 degree inclinations. And that gives you most of the global coverage of the planet. And then the polar shells are sort of the ones that you can build out in unison because they also cover some of the equatorial parts and the greater populated parts of the planet. But why did we see one of Shell 2 and we haven't, and now they're over on Shell 3? It might have something to do with the type of Starlink they want, in particular shells. It might also just be that 3 has less, so they're going to fill 3 first. There's a reason for it, but in terms of polar, a 97.6 degree inclination for these is going to get you a complete view of the planet for the Starlinks that go into that particular orbit. Would you add
There you
anything
go.
to that, Thomas?
Nope, I think you nailed it. Perfect. So thank you to that question there. A couple other messages that have come in here. Starship 24 with another super chat, so thank you for that. Arcadia with a PadRat membership, so thank you. And Stefan has a message saying, shout out to my 10-year-old son Fernando, staying up very late to watch this launch and knows more about space than his teachers. I think we can relate with Fernando a lot there. Fernando, thanks for watching. Hope you enjoy the launch here in just under 5 minutes. Ship 24 with another message saying, can I go to Vandy to make Jack happy? I don't know. When are we going to see starships at Vandy? I'm sure that might be in the future plans.
Ooh, it's Slick 6, please. Pretty please, Slick 6
Ooh, there you
Starship. That'd be
go.
amazing. That would be
That
amazing.
would be fun. Ms. Gwolf says, someone mentioned the Starship. Starship scares the fog away. All right, sounds good. Appreciate that. Nitsuit says, here's money. Well, thank you, Nitsuit, for the support.
Here's
Appreciate that. Straight and to the point. And Multispace Industry says, hashtag Thomas Fan Club. Multispace, appreciate the support there, and thanks for tuning in. Here is a question that I know our good friend Chris is going to have a cool answer to. Big Knowledge wants to know, has there ever been a crew launch from Vandenberg?
No. It's a great question. There were plans it was called the Manned Orbital Laboratory Program for the Gemini program. Would have been a government version of Gemini. And would have resulted in a polar orbiting space station that was serviced by Gemini crews. So there were some plans for it that originated back then. This is actually where Slick 6 that Jack just mentioned originated for. And that never actually came to be, never actually came to fruition. The only actual launch of that program ended up being out of the Cape. And it was just a re-entry test of the Gemini capsule. And then after that, Slick 6 sort of got repurposed for the space shuttle program because like Gemini space shuttle had visions of launching from Vandenberg when it was going to be the US's sole launcher for everything, and there were going to be a bunch of Department of Defense missions that were flown out of there, as well as the potential for crewed flights to polar stations like that for the military. But that program was really plagued to begin with, and some of the things they were trying to do to the solid rocket boosters were absolutely not safe. Lots of problems getting the sound suppression and the acoustic environment right out there, and then ultimately the Challenger disaster in January of 1986 ended any plans for human spaceflight out of Vandenberg, and there are currently no plans for that.
I don't watch For All Mankind, at least not yet, but I think the Manned Orbiting Laboratory is part of that show. Like in the alternate history aspect, like that actually happened. I could be wrong though. Either way, it would have been cool if it actually did happen.
Would have been.
Slick 6 is an amazing launch site, and I'm super curious to hear more about the SRBs and like the contour of the Earth, like all the mountains and everything, and how that would have affected shuttle potentially everything it had to do it. If you have something to read about that, recommend it to me. But we're about like 2 minutes away from launch, so I'm going to shut up and get on my camera. Bye. Thanks everybody for watching.
Bye, Jack. Have fun.
Enjoy the liftoff, Jack.
Absolutely. We are just under 2 minutes away, and I'll take one last question before the final minute. Someone just asking, why is the booster suffix a -10 when it has only flown 9 previous missions? The dash number comes from the mission it's about to launch. So a booster on its first flight has the -1 at the end of its mission. So this is a -10 booster because it is flying its 10th flight. And actually, that number gets iterated as soon as the booster successfully lands. So a booster on its 9th flight that has successfully landed on a drone ship or something gets the serial number gets iterated to its -10 number. So that's how the booster numbering works.
And we are also seeing the very strong and stable vent here from the Falcon 9, that final vent that it does right before a good liftoff is on tap. So under a minute to go now until the launch. So at this point, the Falcon 9 is in startup and is taking control of the countdown. And the first and second stage tanks are pressurizing to flight levels. And under 45 seconds, so at this point, the launch director will have given their final concurrence to launch.
All right, Thomas and Chris, I'm going to leave it in y'all's hands here. You can fight over who talks while the rocket goes. But we are also going to turn on that field microphone that Jack's got out there, so we'll listen into the sounds of the rocket. Remember, it takes some time to come across the valley there for the sound to reach Jack's microphone, but I'll bring that up.
Physics in action, right? Science in real time. But there goes the sound suppression system. So standing by here for engine start. There you go. And there you go. A liftoff of the Falcon 9 from Vandenberg with 46 new Starlink satellites for the third shell of the constellation. And there's the fog,
Merging
everyone.
through some clouds. That was cool. That was a cool shot.
But let's listen for that sound.
T plus 20 seconds.
Crackling roar of the Merlins gets me every time there, Thomas. But there is the contrail. So far, so good for Falcon 9. Just over a minute and 14 seconds into the flight now. All systems good aboard the vehicle. Good trajectory so far. That contrail totally normal and something that routinely happens with liquid-fueled rockets as they ascend through the 9 to 11 kilometer altitude region there, just as all the sort of dynamics are correct to create a contrail in that liquid fueled trail that it leaves.
And it also happens right around the time of the vehicle going supersonic and then going through maximum dynamic pressure. The vehicle's cleared both of those milestones now. The next milestone will, of course, be main engine cutoff for MECO. The engine's currently firing at full throttle after the throttle bucket. And we'll get ready for MECO stage separation and upper stage ignition here shortly.
Indeed, and you can tell Falcon 9 very much ascending into that vacuum as the air pressure lessens, and that bright orange flame, nothing's actually changing with the flame or the fuel mixture. It's that the change in how it appears is because of the air pressure difference as Falcon 9 ascends into the vacuum of space there. So, oh, and there we go. That would be BECO, booster engine cutoff. And there we go with good staging. Alrighty, and a good ignition of that Merlin vacuum engine, which is exactly what we want to see. And of course, they pop the payload fairings very quickly on these two. So there they go, successfully away as well. And now, Thomas, this is the part of a Falcon 9 launch that I absolutely love, the dueling altitudes and speeds of the stages.
Yeah, absolutely. You're seeing two vehicles taking very different trajectories here. So the first stage is, of course, no longer firing its engines. You'll see some periodic RCS thrusters firing. Also, you see that the grid fins have deployed for aerodynamic control here in a little bit. But the RCS thrusters are going to be gradually orienting or rotating the first stage so that it's facing the correct way for the entry burn at the time that it needs to. But right now, it's kind of just floating in space. It's up 110 kilometers, so above all of the different definitions of the boundary of Earth's atmosphere and space. Still, a very small amount of atmospheric drag at that altitude, but not too much to affect the booster's flight path. And the booster will just slowly maneuver its way to the reentry burn attitude. And in this time, it's going to be coasting up to an apogee or a highest point on its trajectory. You'll see the speed gradually decreasing on the way up. And then once it hits that apogee, go ahead, Chris.
I just since it's on screen, that's ice coming off the booster.
Sure,
Just for
yes.
anyone wondering, that is ice coming off the booster. It's totally normal.
It's like, oh, right there at
Absolutely.
410, the little thing moving to the left. Like, what's
The alien,
what is
the
that?
alien, yeah.
Is that half a Stargate? What just came off
It
the
changed-
rocket? Like,
It changed direction. It must be a UFO.
whoa, Jack, hi.
Anyway, Thomas,
Sorry,
since it was on screen, I just wanted to hit it right when it was on screen.
Yep, of course. And that's, of course, from those RCS ports as well. The first stage, though, as it hits its apogee, in fact, you can see that it has hit apogee because the speed is now increasing again. So an apogee of just around 122 kilometers, and the first stage is now being pulled by gravity back down, and the speed is increasing as it approaches its entry burn in just a minute or so. Meanwhile, the upper stage is, of course, flying a very different trajectory under the power of a single Merlin vacuum engine. You can see the speed continuously increasing much faster than stage 1 already, 11.5 kilometers, or 11,500 kilometers per hour. I thought it was going to be meters per second, so I'll be fancy and convert it to kilometers per second in my head. That's not the telemetry, though. So 12,000 kilometers per hour now, and an altitude of 162 kilometers now. So well into space and accelerating horizontally so it can achieve a low Earth orbit. The upper stage will be going into a low Earth orbit, or low Earth parking orbit initially, and there will be about a 45-minute coast phase after SECO 1 before the upper stage does a very brief 2-second burn to circularize the initial orbit and deploy the satellites. The satellites, of course, from that orbit will do their own maneuvering and raising up into the operational 560-kilometer orbit in the third shell of the constellation. But both vehicles following a nominal trajectory right now. The next milestone is that reentry burn, and you'll see that the stage on your left will finish maneuvering to the reentry attitude. You'll see the grid fins become active shortly after the burn, and this burn is going to slow down the vehicle and protect itself during that first phase of reentry. You can see the stage has stopped rotating. It's in the orientation for the entry burn, and so let's take a look at those. First the center, and then the two outer ones as well, for 3 total engines to ignite on the reentry burn. There's the grid fins locking into place, getting ready to do their atmospheric steering. There is ignition of the central Merlin engine, and 2 more, so now 3 Merlin engines firing for this reentry burn. Stage 1 again headed towards Of Course I Still Love You.
Indeed, and look at that velocity on stage 1 just drop dramatically with the engine firings. And what I love here now is on the Starlink returns, that velocity increases again. You saw it, go up, and now it's
just a little bit. Yep.
And now it's just all the atmospheric drag that's just slowing this booster down at this point, and because you're really in the you're getting into that thick, dense lower atmosphere there.
And
as it did the 80s style rewind.
Yeah, not too surprising that the video feed is a little inconsistent during reentry there. Still getting some telemetry on the bottom left, but it looks like that might not be updating as consistently also. So we're going to keep an eye on the telemetry, also keep an eye for a video feed to come back either from the drone ship or the booster itself. Stage 2 looking good so far as well. Both vehicles appear to be nominal, just waiting for kind of to regain that feed from stage 1.
Yeah, and there's about 7,000 kilometers an hour that's left in the acceleration needed there for the orbital velocity for stage 2. Looking for about 27,000 kilometers an hour. But look at the vapors on the booster.
Yeah, stage 1 video feedback, and you definitely see the transonic effects as the stage 1 goes from supersonic to subsonic after it just went the other direction a couple minutes ago.
So if you were in the landing vicinity, you would be getting ready for the triple sonic boom right now.
And there is ignition of the landing burn. You can see the drone ship. There's Of Course I Still Love You. And then on the right-hand side, a view from the ship itself.
That's
Grid
beautiful.
fin steering its way.
Ooh.
Landing like deploy. And
Boom.
touchdown.
Oh,
That
I
is
don't know,
booster.
SpaceX. That's not very much in the middle. Come on.
Oh man,
We're all
everybody's a
spoiled.
critic these days.
We're so spoiled.
But we got some pretty solid video feed of that landing there. That's booster 1061-11 for those keeping track. 10 flights under its belt now.
I like another
Indeed.
successful landing, in part because yay reusing rockets, and also in part because yay not throwing rockets into the ocean. But also, now we get to watch that come into the port of Los Angeles on Fleet Cam in a couple days.
You
And
too,
there's
indeed.
Seco 1 as well. So the upper stage in its initial orbit, again, a coast phase coming up. We will not be staying live for that, so stay tuned for the final update from SpaceX on Seco, the second engine burn, and then a payload deployment. But stage 1, safely aboard, of course, I still love you. That stage is now flown from all 3 of SpaceX's Falcon 9 launch pads. And that's cool. A
And
view from the interstate,
it-
just looking up into the sky after landing. That was cool.
Looking up, like, here I am. And I also just want to point out the speed. I forgot. It's a retrograde orbit. So 28,000 is what you need, not 27,000. So different orbits require different velocities. Remember that. So
Because
yeah.
the Earth
So
rotates.
because you countering Earth's rotation. Exactly.
All right. So that is looking like we're not going to get any more cool booster views on the barge, the drone ship, whatever we're calling them these days, from SpaceX. But I had to show my favorite view on the left.
The
The
empty
launch pad with no rocket on it, because we got to see a Starlink Falcon 9 launch out there from Vandenberg, but we're not done doing things for today, y'all. On the right-hand side, we've got a live feed coming in from Starbase, and you can see that's actually Booster 7 that seems to be making an escape. It rolled a couple of bits of flame out of a Raptor on the bottom twice now, a 20-second fire. What was it, yesterday that they did that 20-second fire?
Yeah.
Time flies. And it looks like they are rolling Booster 7 maybe back to the production site. Remember, there were only 20 engines on the outer ring there. So maybe they're taking it back to the high bay to put some more engines in it to continue its test campaign.
So
But,
does that mean there's another launch pad without a rocket on it now?
Yes.
But it's not a
Does
launch
that
phase, so
mean-
it's different.
Right. But
It is definitely not a. It's definitely not a rocket on a. I'm confused. Okay. Anyways, this one's gonna go back. It's gonna get more engines than we hopefully see it fire again.
Yes.
Okay.
yes. Yes.
All right.
So what we would want to direct everybody to is Starbase Live, the 24/7 camera feeds from down in Starbase, because we're going to be wrapping up our coverage of what appears to have been a very successful Starlink launch so far. Stay tuned to SpaceX and to NASASpaceflight.com for the final updates on the rest of that ascent. But if you want to check in with Booster 7, who's going to, like Chris or like Das said, rolling back for potentially the rest of those Raptor engines, go ahead and check out Starbase Live. Those cameras are live 24/7, keeping an eye on everything SpaceX is doing in Starbase. Also, really quick, just a couple quick super chats. Jerwa gifted 10 Red Team memberships. So, Jerwa, thank you for your generous support today, as well as a super chat from Morph and one from Davey Blair saying, "Thanks, NASA Spaceflight, for providing me with great coverage of this candle being lit for my birthday." Davey, happy birthday. Thanks for tuning in and for the support.
All right. Man, it
And a
wouldn't
thank
be
you
a
from
stream.
Robot Jack as well.
It wouldn't be a stream without a robotic Jack there. Jack, thank you so much, Robo Jack, at the very end of the stream. Oh, anyways, I'm sure Jack was saying something heartfelt and just tearing at our heartstrings about experiencing that launch today. Maybe you should follow him on Twitter to make sure you can catch up with Jack. But thanks members. Here we go. We've received a text update from Jack that says thanks to the members for making this possible. That's what we were trying to say there. And his patrons as well. He would like to also thank his patrons. He would also like to thank the super chatters. I'm not sure what a super chat year is, but that's what he typed. Anyways, folks, we do need to go ahead and spool down the stream here. Oh, he did a facepalm emoji too. Okay, so a facepalm emoji from Jack as well out there in the field. Hey, really quickly, we had Chris Gebhardt on. Chris, thank you for joining us today.
My pleasure.
And Thomas Berghart was on as well.
Yeah, thank you, Das.
Jack would like to represent himself with a picture of a spinning dolphin head, it looks like. So Jack Beyer out there as well. in the field, running the cameras for us today. He does need to pack that camera up, so we will go ahead and let him go by shutting down the stream. I'm not going to do this fancy matching thing, but when you're done, head on over to Starbase Live. It may recommend that as the next stream coming up here. For now, we are going to go ahead and shut this one down. Now he's going to just get in front of the camera, it seems. And we will see you nerds later. Thanks for watching, y'all.
We have liftoff. Propulsion continues to be normal.
The chamber pressure looks good. Toggling up. Roger, roll, Atlantic.
Water towers, fly! Yes!
Echo Delta nominal.
Flight outside, SCE off. Say again, SCE off. Off.
Yikes. You bet. Concur. We don't need any more of these.